Alright, let's do problem 11, container with most water. Here we're given an integer array of heights and we have to work out the maximum area of water that can be stored by any of those two lines. So example 1 shows good illustration of the problem. So we can see that the max water is bounded by those two red lines. The reason the tall black line isn't considered is because we have to take into account of length as well as height. So suppose we have the following example, and to solve this question we do need a 2-pointer. So we do have a left pointer and a right pointer on each side, and as for any other 2-pointer problem we do need a while loop while left is smaller than right. And even before thinking about the logic for moving the pointer, we do know how to work out the amount of water. So we're going to call it current area. So current area is nothing but length by height. So the length is r minus L. And then which height should we choose? We have to choose the shorter height because the area is bounded by the shorter height. And we have to update our max area. So we basically check if current area is greater than max area. In that case we assign new value. So max area update. And then what's the logic for moving our pointer? So it's very logical to say that we have to move the pointer with the smaller values. So we can say we can see that r is shorter than L, so we have to move r to the left. So we're basically finding a potential height that's going to give us the maximum area. So by doing this we are iteratively getting a new area and then updating our max area. So if left is smaller than right, we have to increment our left pointer, and otherwise we decrement our right pointer. Okay, so that's the logic. So let's put them in code. So we have int left equals 0 and the int right equals height length minus 1. And we have int max area equals 0, and then we have while loop as the while left is smaller than right. Here we're going to work out current area, but before we do that we have to find the shorter height. So I'm going to call it current height equals, we can use math.min method. So simply put the values that each pointer are pointing. So height left and then height right. And let's work out the current area now. So current area is simply length, which is r minus right minus left, multiplied by current height. And then we have to update our max area. So max area equals math.max. So we have to put current area and max area. Right, and then it's time to move our pointer. So if height at the left is smaller than height at right, we have to move our left pointer. So left plus plus. Otherwise we have to move right minus minus. And that's it, and then we use as return max area. Okay, let's run the test. It's passed, let's submit. Okay, it only beat 70% of the solutions. Okay, so there's a reason for this one. So suppose we have a lot of shorter lines here, and then it was like really long here, it's like this as well. So after our first iteration, it's time for a left pointer to move because right pointer is taller. So when we move to the shorter one, we do know that the area will be smaller, but we have to repeat this multiple times until we get to this line, because that will be the amount of water, the maximum amount of water stored. So it's very inefficient to work them out over and over again, knowing that the next value will be shorter than what we have now. So to prevent that, we can actually use while loop. So let's remove if and else statement, and then we can have while loop. So while height at left is smaller than, or we can ignore the equal one, because even if we have the length of the same size, so R is here, but initially we are looking at this. So even though we get the length of the same size, it will be smaller than what we have. So there's no point in going to that. So that's why our inequality is less than or equal to. And what are we comparing with? We are comparing with the current height, because that's the smaller one. And we just do left plus plus. But we can't just go on and on and on. There should be some limit. It can't go beyond R. So we have to make sure left is smaller than right. And then we're going to do the same thing. Height at right is smaller than or equal to current height. And again, right shouldn't be smaller than right shouldn't be smaller, so it should be greater than left. So it will be right minus minus. Okay, and the reason this one works, the left is smaller than current is actually equal to current height, so we're going to go to the next lines until this pointer. But right, this one won't be called because we do know the height at right is taller than current height. So even though we have two while loop, we're essentially calling one of them unless both of them are the same size. Alright, and let's run the test, see if it works. It's passed, let's submit. Okay, now it beats 99%. It can also be 100% if the internet speed was a bit faster, but yeah, I'm happy with the result.